Hello everyone. Today we discuss about four different types of operation which is performed by 8085 CPU or also known as MPU, that means microprocessor unit. The four different operations are done by 8085 microprocessor, which are, first of all, this is a very important, that is memory read operation. Second one is memory write operation. This memory read operation is also known as memory read. This is active low signal, that's why it is complement sign. Memory write signal is also known as MEMW bar. Third one is input output read operation, which is also known as IO read bar. And number 4 is IO write operation, which is also known as IO write bar. So basically any microprocessor or any MPU have four different types of section. The first one is related to memory and another two is related to the interfacing device or IO device which is connected to the 8085. So basically I again repeat that in 8085, basically for any microprocessor there are basically two external peripheral connected. Let us consider, if we consider this is an MPU, so here one block is connected to MPU with MPU and another block is connected to MPU. This is known as IO device and this is known as memory unit. The memory unit where we store the operating system or store code and running the code from this memory to and fetching the instruction from this memory to microprocessor, and data also save in this memory. But what is input output device? Input output device is basically a port which is used for the different kind of IO actions or any kind of automation are performed, or any kind of PLC operation, programmable logic array, or any kind of industrial applications, and also using with the help of peripheral chips also. And that's why these IO device is most important. And in basically 8085 development board, there are basically two input output device are connected. One is very important, that is from keyboard where we enter the hexadecimal number for instruction and address also, and another is for 4 plus 2 digit. 4 digit 7 segment is used for address and 2 digit 7 segment used for data. Okay, so basically first of all this is a four basic operation of which is done by MPU. So now we know that in a 8085 processor, in the previous video we discussed about the pin diagram of 8085, but here one problem is created, because in a 8085 there are 4 pins are available. That means IO/read bar, M bar, one is read bar and another is write bar. So now the question is arise. So in 8085 only these three control signals are available. So how we get this signal? That means there are 4 control signal are generated from this 8085. So actually this is not generating from the 8085 directly. So here we connected one external hardware. This is an external hardware. Okay, this is an external hardware from which we generate 4 different control signal. This is for IO read, this is for IO write, this is for memory read, and this is for memory write. So basically here we use different types of logic gate, or here we use 3:8 decoder. But how decoder will be controlled? So now make it very clear. So basically we have 3 different control signal. One is IO/M bar, one is read bar, one is write bar, and here perform control actions. So first of all, these are 2 zeros. 0 means memory related operation. Okay, and if we active low this read bar pin and this is active high, so this is called the memory read operation. And if this is 1, this is 0, then this is called memory write operation. When this is 1, 0 and 1, and it is called IO read bar. And when this is 1, this is 0, this is known as IO write bar. Okay, so for control signal generation. So now what are the logic? When input is 001, then we get memory read bar. So now we here take one decoder. Sorry, now here we take, just a minute, I shown in a different color, so that's a much better understanding. So basically I use here one decoder, okay, which is known as 3:8 decoder, and here we apply three different control signal. One is IO/M bar, one is read bar, and another is write bar. Okay, so now from here 4 outputs are available, from where we get this 4 different signal: IO read bar, IO write bar, MEM read bar, and another is that, which is another important signal, is memory write bar. Okay, so what are the logic here? So from memory read bar, the logic is 001. That means this memory read bar is coming from Y1, because 001 is a binary. So what is the decimal equivalent? That is the decimal equivalent digit is 1 in a decoder. Next one is 010, that means 2. Next one is 5. Next one is 6. This 101 is a binary. This 101 is a binary form of 5. So that's why we write here 5. So from Y2 we get memory write bar. From Y5 we get this, and from Y6 we get this. Okay, this is Y1 from here. Not here. I again show it. So there are 4 control signal generation basically. So basically this is Y1. Okay, memory read bar. This is Y2. Okay, this is also bar because this is active low. Then 101, that means this is Y5 bar, and this is Y6 bar. Okay, so now using this 3-line to 8-line decoder, we can manage it to generate 4 extra control signal generation, which is not directly generated from the 8085, but using the external hardware like this. Using this external hardware, this is external hardware. So this is an external hardware, which is also known as 3:8 decoder. So this is the decoder chip. The practical decoder chip is 74LS138. LS is a technological version, standardization. Different types of technology are available. LS means low power Schottky. ALS means advanced low power Schottky. There are different types of technologies that are available depending on the speed operation. Different types of speed operation of TTL or internal BJT circuitry. Okay, that's all for today. Thank you.